We're going to explain the dreaded java.lang.unsatisfiedlinkerror in the Dalvik System PathClassLoader. This error typically pops up when your Android app tries to use native code written in C, C++, or other languages, not Java, and something goes wrong with loading the native libraries. Think of it like this. Your app needs a specific tool, the native library, to work, but it can't find it or it's broken. Let's break down the common causes and how to fix them. 1. Missing or incorrect native libraries. The most frequent culprit is a missing ISO file, shared object file. These files contain your native code compiled for the specific Android architecture, ARMIA BY v7a, ARM64 v8a, x86, x86-64. Ensure you've included all the necessary TASO files in the appropriate JNI libs folder within your Android project. Double-check the architecture compatibility. If your app is built for ARM64 v8a, make sure the TASO file for ARM64 v8a is present. Inconsistent architectures between the app and its native libraries will lead to this error. 2. Incorrect library naming. The name of your .so file must precisely match the name used in your Java code when you're loading the native library using System Load Library. Even a slight typo will cause this error. Carefully review the library name in both your Java code and the file system. 3. Build system issues. Problems with your Android build system, Gradle, can prevent the native libraries from being correctly packaged into your APK. Check your build.gradle file to ensure the native libraries are included correctly. Cleaning and rebuilding your project often resolves this. You might need to specify the correct ABI filters to only include the necessary architectures. 4. Incorrect path. Although less common with the PathClassLoader, there might be an issue with the paths defined in your code. Make sure System Load Library is using a correct relative path or an absolute path if necessary. Relative paths should start from the application's installation directory. 5. Library conflicts. If your app uses multiple native libraries that depend on different versions of the same shared library, you might encounter conflicts. In this case, you'll need to carefully resolve these dependencies, perhaps by upgrading or downgrading library versions. 6. ProGuard R8 issues. If you're using code obfuscation tools like ProGuard or R8, make sure they are configured correctly to handle the native code. These tools might rename or remove things that your native code depends on. Carefully examine the ProGuard or R8 configuration to avoid unintentionally affecting the native library's functionality. 7. Permission issues. In rare cases, file system permissions may prevent the app from accessing the native libraries. Ensure that the app has the necessary read permissions for the directories containing the .so files. This is less likely, but worth investigating if other solutions fail. To debug, carefully examine Logcat for more specific error messages. These messages often provide clues about which library is missing or what's causing the issue. Remember to clean and rebuild your project, double-check your library names and paths, and make sure your architecture compatibility is correct. By systematically checking these points, you'll increase your chances of resolving this frustrating error.